everyone, thank you for this opportunity to talk about animal-friendly affinity reagents and the significant progress that has been made in this area to replace the use of animals, not just by myself, but importantly by others, without whom none of this would have been possible. An affinity reagent describes a molecule that has a very specific affinity for another molecule, the most well-known example being antibodies, which are generated as part of our immune response. An antibody has two very specific binding regions, as circled here in red. Owing to these regions, each antibody can bind to a part of a foreign object, such as a bacteria or virus, and neutralize it. So valuable is this property that scientists have long exploited it by injecting the target of interest along with immunity-boosting chemicals into animals, causing them to generate an immune response. The antibodies that are generated as part of this immune response are tailored to recognize only the target of interest and are extracted from the animal for use in many different applications. But this industry is heavily reliant on animals, and this needs to change. So first and foremost, let's briefly deal with the welfare issues. This issue is of concern in terms of both numbers of animals used every year and the degree of suffering. To give you an idea of the scale of this, the global antibodies industry is currently worth around $80 billion. Now, contrary to the widely held belief that immunisation is nothing more than a pinprick, similar to that which might be experienced during vaccination at your local surgery, in reality, the welfare issues range from mistreatment of the animals or effects of the immunisation procedure itself, which is reported in the scientific literature. Immunisation can generate a wide range of reactions from mild to severe, or from localised, such as inflammation or ulceration, to systemic, such as tremors or anaphylaxis, etc. And this is because the target of interest can be anything really. It can be an irritant, a carcinogen, a pathogen, or other toxin, or something non-toxic, but the reaction often can't be anticipated in advance. In terms of numbers of animals used, we're talking about an estimated 1 million animals per year in the EU and a 5-fold increase worldwide. And owing to the scientific interest in this field, there will always be limitless new possibilities for new antibody candidates and procedures. Further to the immunisation procedure, antibodies can be amplified using the ascites method, and this was banned in 6 EU countries due to its severity, and yet 45,000 procedures were reported in 2017 in the EU alone. In addition to the welfare issues, hardly any of us are aware of antibody use in consumer society, but the reality is that animal-based antibodies are incorporated into tests that we're not aware of, and often used in tests that are considered to be animal-free. To paint a full picture, society is largely unaware of how it touches our everyday lives. For example, when we visit our local supermarket, need medical attention, or are planning a family. Animal-derived antibodies are incorporated into diagnostic tests and therapeutics, fertility, food and environmental safety, efficacy testing, chemicals testing, and finally cosmetics testing, where animal testing is supposedly banned. To look at this from the scientific perspective, animal-derived antibodies have a bad reputation. Scientists have been relying on animal-derived antibodies for many decades, aware and resigned to the fact that they have many disadvantages that hinder research owing to the method of production. There are hundreds of articles complaining about their quality, and sometimes it's years of research and citation before the fault is identified. This has a resounding impact in terms of wasted cost, time and resources, a reported annual loss of $800 million to the biomedical research community. There are also repercussions on diagnosis and health management, which is simply something that the research community, publishers or funders should not be tolerating. Then an especially good reason for moving away from animals is that we actually have replacement methods. And according to Directive 2010/63 EU on the protection of animals used for scientific purposes, alternatives should always be used where they exist. Instead of relying on animal immunization, antibodies can be generated in microorganisms. In this diagram, circular pieces of DNA are made containing the sequences of billions of antibodies, all with different binding regions programmed into their genetic code, so that each antibody, once produced, will only recognize one target each. Each circular strand of DNA is transferred into a bacterium. Then we introduce a virus known as a phage that uses the bacteria as a host to replicate itself. When the phage replicates itself, it also replicates the unique antibody that was transferred into the bacteria. The phage displays the antibody on its coat, where it's readily accessible for scientific applications. This technique is called phage display, and here we've created an antibody phage display library, and this contains billions of antibody candidates. So clever is this technology that the scientists that pioneered it were recognized with a Nobel Prize in 2018. So, AFFINITY was launched in 2016 with the mission to replace animal-derived antibody production methods with animal-friendly affinity reagents that do not require the use of animals, and thereby encouraging better science and significantly reducing the numbers and suffering of animals in the biomedical sciences. AFFINITY challenges the enforcement of Directive 2010/63/EU, improves accessibility of replacement methods, and creates awareness of the use of animal-derived antibody production methods by all scientific disciplines. So it was firstly necessary to improve awareness of the animal-free technology. Initially, 2 articles were published in high-profile journals that presented the arguments and called for change. Then, to cut a long story short, as a result of the impact of these articles, through approaching the EU, being very persistent and then formulating a strategy with them, an EU recommendation on antibody production was eventually released in May 2020. This has completely changed the landscape for antibody production. In short, the recommendation states that animals should no longer be used for the development and production of antibodies for research, regulatory, diagnostic and therapeutic applications, whenever a replacement is possible. So now we're seeing significant activity at member state level to implement this change. The recommendation is by far my proudest achievement, but also further high-profile articles were published by the Nature group of journals, and so further awareness was generated. Now, the EU recommendation recognises that additional measures should be implemented at member state level. Significant barriers to uptake still exist. Some barriers that previously existed are being eliminated, such as lack of awareness or scientific misconceptions, but further measures are required to improve accessibility to resources, training, expertise and funding. To meet such challenges, AFFINITY has an ongoing laboratory programme of antibody development at the University of Nottingham in the UK, where phage display libraries are being developed. These resources, including training and technical support, will be made available to the scientific community without any contractual commitments. And with that, I will finish this short overview, leave you with a few links for further reading, and say thank you for listening.